Welcome back to the Block Search Repair YouTube channel. Today we're going to be working on this soccer shot coin pusher. Honestly, I didn't expect to be making any more videos on this thing. I thought it was pretty much finished, but we're not. In the last part, the soccer ball here on the left side was a lot dimmer than the one on the right, and I figured there was some kind of overvoltage going on the one on the right. Maybe there was a light bulb out somewhere else in the line that should have been dragging the voltage down a little bit that wasn't, but no, apparently the left side was the issue because now it no longer lights up whatsoever. So I went to the PCB, took the oscilloscope to it, and I was getting the proper triggers to turn on the transistors. And I figured all three transistors, because the bulbs turn on individually, couldn't possibly have blown, and so I did some probing and discovered I didn't have 24 volts on this PCB. Which is weird because I figured they both got 24 volts from the same place, just possibly on a different fuse. So then I decided to take a look up here, the power distribution block. We have problems. As you can see, there's a lot of blackened board there from heat damage, there's a lot of corrosion from moisture damage, there's just a lot of damage to that PCB. We're gonna have to pull that out and take a closer look at it. Unfortunately, pulling the board out doesn't make it look any better. It looks like there may have been some moisture being blown in by the fan directly above this board, directly onto this circuit board. I'm gonna go ahead and make sure these caps are discharged. They are only 25 volts at 33,000 microfarad. But when I drop these in a, stainless steel ultrasonic cleaner, I don't want them shorting out. So we're going to make sure they're nice and empty. There we go, a bit of distilled water and a bit of the corrosion remover. I didn't add too much corrosion remover. I might have to run it in a second time. I think this first batch is mostly going to get all the dirt off, and then maybe we'll have to run it for a second batch to get the rest of the corrosion off, but we'll find out. And there we go, fresh out of the ultrasonic cleaner. We're going to throw this in the oven to dry it off, then we'll take a closer look and see what's wrong with it. Drying the board off, this is what we're left with. It's a lot better than it was, but as you can see, there's still definitely some issues going on here. We got all these traces that are burned black. We need to see if we have a broken trace. I checked all the fuses. All the fuses were good, so that's unfortunate, because that means something actually has failed, and it's not just a fuse blew. Luckily, the other side of the PCB is actually in incredibly good shape. I mean, yeah, there's a little bit of damage there, but compared to this side, yeah, this side looks amazing. So it's definitely going to be something probably on this side. Let's just verify all the traces to and from our fuses, and then we'll go further. So after verifying on the machine, it looks like these connectors here are just straight inputs through to the PCBs, which means our middle wire should be where our 24 volts should be. So on one of these connectors, we should have an issue on the middle pin. As you can see, we don't have continuity between the two, but that makes sense. They probably have them separate, so if one side breaks, something on that 24 line shorts out. Doesn't kill both sides of the machine, it'll just blow one of the two fuses most likely. But let's go through and figure out which side has an issue with our 24 volt line. I gotta go through and figure out where our 24 volt line even goes, which fuse is responsible for it, etc, etc. If we take a look here at this PCB on the underside, these are 24 volt pins. As you can see, one goes to right here before it goes through there and then goes through the other side. This one over here goes through right here. So one of these has an issue. Let's verify that we have continuity from that via to the actual pin on that connector. That'll at least verify that the trace from here to here is good, and the trace from here to here is good. So it's somewhere behind these vias that has our issue. Let's flip the board back over and see what's going on here. Weirdly, there's some burning in this connector right here. It's kind of blackened, so I'm wondering if we honestly don't have an issue, and it's just this corrosion inside this connector right here was causing our issue. But we'll go a little bit further before we figure out if that was actually just a simple corrosion issue causing our no lighting. Unfortunately, those vias go into where the transistors are, which is kind of hidden by a giant heatsink. So let's see if we can remove some of these heat sinks and see if we can get to these transistors, see if we have a blown up transistor or something like that. Maybe it's a MOSFET. That'll actually know. Over the heat sinks, we can have a closer look here. This one right here, this connector, the 24 volts comes from this MOSFET or transistor. I didn't actually check right here. And on this side, it comes from this one right here. So the question is one of these bad, or was it just a simple corrosion issue causing our issue? And what I'm wondering is, since we did have dim lights, and then it eventually went away, is I'm wondering if that it wasn't dim because it had a bunch of resistance right here, only letting a little bit of power through, which ended up causing more heat, which ended up causing more corrosion, which ended up making it so we lost power completely there. What I'm thinking is, why don't we plug this board back in, see what happens now that all the corrosion has been removed due to the ultrasonic cleaner, and see what we're left with, because it might simply work. And if that's the case, then we just need to do a few more things to button this board up, and I think it'll be good. So let's just plug this board back in and see what happens. Okay, so, yep, we definitely have an issue with a transistor, probably, or something before that transistor, because we still don't have lights. I'm gonna wiggle that connector just to verify, but I'm pretty sure. So we do not have 24 volts on the connector closer to the left. The one on the right does have 24 volts. So it is an issue with the power supply. Let's pull this back out and take a closer look. Okay, so they're actually voltage regulators. I'm not sure why I didn't think of that, but obviously they are, after I googled the number, of course. But they both get their voltage from the same location, and one side has voltage and the other doesn't. So obviously one of them's bad. So we're gonna pull them both off, put the good one in, well, the suspected good one in where the suspected bad one is, and we should suddenly have lights on the side that we think the bad one is. That'll at least verify that there's nothing else wrong, and then we can order this voltage regulator and fix this board. After testing them out of circuit, this one is most definitely bad. So, I guess we'll just have to order another one of these. I don't even need to swap these because, well, this one is measurably bad. So, order another one and we should be back in business. The new voltage regulator finally came in, so I've gone ahead and installed it. So let's put this board back in the game and see if that was actually the issue with this board. I think it was. Let's find out. Moment of truth. Does it go bang? Hey, and we have the lights down there. We got the soccer ball lights there. I think they're unplugged, so I think they're just sitting down in the bottom flashing, which is why they're really, like, you can barely see them. But okay, we are, well, back in business with lights-wise, so it was that voltage regulator. Super pretty easy fix. Yeah, and this side was just simply not in their sockets. Let's put them back in, and we should be good to go. There we go. That looks much, much better. Now we need to put a new starter in for that fluorescent tube there, and then we should be able to have that light up as well. Unfortunately, apparently it's not a starter. That tube's bad. I just checked with a voltmeter. The filament is blown on this side, so I guess that is why it doesn't work, besides just the starter. So I'm gonna have to get a new tube for it, so I can't put that together. But there's one more thing we can do. Replace that chip right there. As you can see, it's double stack sockets because I somehow at some point broke off two of the legs of that chip. So I then soldered it to the socket and plugged the socket into the other socket. It works, but we're going to replace it with a new one so it doesn't look like that. I mean, to be fair, it does work, but I can't sell a machine with that. And there we go, new chip installed. Let's make sure this still functions. We are getting a system battery memory alarm, but let's just unplug it and we should be good. And after a quick power cycle, we're back in business. Perfect. That's exactly what I wanted to see. That's exactly, well, all we need to do. We just need to replace that, I believe, 25-inch tube, and we'll be done with this machine, and I can finally sell it. Though I need to replace those light bulbs, because those are actually 12-volt bulbs, and I think they're being given 24 volts, so they're going to burn out and create way too much heat, so we're going to replace those as well. But for now, this thing is almost done. After a bit of searching, I managed to find the back door for this machine, so we'll be able to reinstall that once I find the correct bolts to bolt it on. I also went ahead and got a new fluorescent tube for this. You may be asking, why isn't it installed? And the answer is because, well, I found the tube the correct size at a thrift store for $1. It was brand new, so I'm like, okay, for $1, I might as well just put a fluorescent tube back in this. So I hooked it up. It didn't work. I mean, I guess somebody dropped it at some point and one of the filaments was broken, because I measured and one of the filaments was broken. So back to square one on that. I'm still not sure. I'll probably just replace it with a fluorescent tube if I can find a fluorescent tube. It's like a 36-inch tube. It's not an impossible to find size. It's just not a common size. But if you like what you saw, please leave a like and subscribe. We got a bunch more machines to work on.